Now we are going to see the optimal page replacement algorithm. This is the one important type of page replacement algorithm. So in the optimal page replacement algorithm, we need to replace the page that will not be used for longest period of time. So for that we need to know what are all the future pages, what are all the upcoming pages. So the consider the reference string which we have used for that same FIFO, and the number of frames also 3. So at the same time, the main memory can occupy only the 3 frames. Now, okay, we go with the problem solving. So at first, the main memory is divided into 3 frames. There is all the frames are empty. The page 7 comes. It is not available in the memory. So there is a page fault. We put the page 7 in the memory. Okay. Next, page 0 comes. It is also not available. There is a page fault. We put that into a memory. Next, the page 1 comes. It is also not available in the memory. So we will put that page into the main memory. Okay. So now consider that main memory is full. Okay. Now, okay, the page 2 comes. The page 2 is not available in the main memory. So there is a page fault. Okay, which page need to be replaced? So the page out of the 701 which will not be used for longest period of time in future. So in this time we in this side, okay, in the right hand side we need to see from 2 the distance 2 to this one. So that is 1 is here, but the 7 is here. So the 7 cannot be used for longer period of time. So, 7 will be replaced by that 2. So 201. So next is 0. 0 is already available. There is no page fault at all. Next, the page 3 comes. The page 3 is not available in the main memory. So there is a page fault. Now out of the 201 which we need to replace, the 0 is here. So it will be used in near future. Then 1 is here, 2 is here. The 1 from the 3, 1 distance of 1 is high. Okay, so we need to replace that 1 by 3. Okay, now next 0 comes. 0 is already there. There is no page fault. Next page 4 comes. Okay, now the page 4, okay, is not available in the main memory. So there is a page fault which we need to be replaced out of the 203. 2 is here, 3 is here, 0 is the 0 is in the longest distance. So you need to replace 0 by 3. Okay. Next page 2 comes. There is no page fault. It's already there. 3 is already there. There is no page fault. But 0, there is no 0 is not available. So there is a page fault. So out of the 2, 4, 3 which you need to replace. So from 0 you need to find 3 is here, the 2 is here, 4 is not at all. So you can replace that 4 by 0. So 0, 2, 3. Fine. Now the next one is 3 which is already there. There is no page fault. Next is 0. 0 is also already there. There is no page fault. Next 3. 3 is already there. There is no page fault. 2 is already next to 2. 2 is also already there. So 2 is also there. So there is no page fault. Next we have 1. Okay, but 1 is not there. So there is a page fault. So out of the 203, which one we need to replace? 2 here, 0 here, 3 is not there. So 3 has to be replaced by 1. Okay, next 2. So already 2 is there, no page fault. 0 is there, no page fault. 1 is there, no page fault. 7. So out of this 201, which you need to replace to take 1, 7. So from 7, 0 is there, 1 here, there is no 2. So we need to replace that 2 by 7, that is 701. Next 0, which is already there, no page fault. 1 is also already there is no page fault. Okay, so we calculate count the number of page fault. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here the number of page fault. So the number of page fault is 9. So for the same reference string and the amount of frames, so the optimal page replacement algorithm has a number of page fault. But in FIFO for the same we have the page fault is 15. So then compared to FIFO, the optimal algorithm produces the best. Okay, well, because the number of page fault happen is less. So if then FIFO, the optimal page replacement algorithm is best. Thank you.